Okay, today we're going to talk about graphing linear functions. You have seen linear functions written in the form, that should say y equals mx plus b, not just equals. Y equals mx plus b. By naming a function f, you can write it using what we call function notation. And function notation is where you use f of x equals mx plus b. The symbol f of x is another name for y. Okay, so we're essentially going to be doing the same things. It's just instead of y, we're writing f of x. And you read it as the value of f at x, or simply f of x. It does not mean f times x. Okay, a lot of times people see the parentheses, and in any other situation it might mean multiplication, but this is read f of x, or f when x is, that kind of thing. You can use letters other than F. We could use a G, an H, a P. It really does not matter. Okay, so the first thing we're going to work on is evaluating the functions. So for number 1, it says evaluate the function f of x equals 3x minus 15 when x is negative 3. Okay, so we're figuring out, well, what is f when x is negative 3? So we just plug in 3 times negative 3 minus 15. I'm just plugging it in here for x. So f of negative 3 would be negative 9 minus 15, which would be negative 24. So it's evaluating. We've done it a million times, and we're just going to keep doing the same thing. Okay, number 2, evaluate h of x when h of x equals negative 7x when x is 7. So h of 7 is negative 7 times 7. So h, when x is 7, is negative 49. And then number 3, for the function f of x equals 2x minus 10, find the value of x for that f of x equals 6. Okay, so this time, instead of giving us the x, they're giving us the f of x. So f of x is 6, and that equals 2x minus 10. Right? So over here, because the function was f of x equals 2x minus 10. So since f of x is 6, I just put that in here. So we're going to add 10 to both sides to get 16 equals 2x, and divide by 2 to get 8 equals x. So we just figured out, okay, well, if the value of f of x is 6, then x has to be 8. Because 2 times 8 is 16, minus 10 is 6. Okay, so now we're going to talk about domain and range. It says the domain of a function consists of the values of x for which the function is defined. The range consists of the values of f of x, where x is the domain of f. Okay, so f of x is just, remember what it said up at the top. This is just another way of saying y. So we know already that x is the domain and y is the range. So there's nothing different here, except instead of calling it y, we're calling it f of x. Okay, so let's talk about the gray wolf. Okay, it says the gray wolf population in central Idaho was monitored for several years for a project aimed at boosting the number of wolves. The number of wolves can be modeled by the function f of x equals 37x plus 7, where x is the number of years since 1995. So it says graph the function and identify its domain and range. Okay, so we're going to let's put in a 0. Okay, so that would be in 1995, right? Because that's 0 years since 1995. We can put in 37 times 0 is 0. 0 plus 7 is 7, right? So when we put that in, right, I did 37 times 0 plus 7. So in 1995, there were 7 wolves. Okay, well, what about 1 year after 1995? We're going to do 37 times 1 plus 7. So that would be 44. And then what about 2 years after 1995? 37 times 2 plus 7. So 37 times 2 would be what? 74 plus 7 equals 81. Okay, so 0 years after 1995, we had 7 wolves. Then 1 year after, we had 44. And then 2 years after, we had 81. So I'm just going to go ahead and count by 20s. 20, 40, 60, 80. And then this is 0, 1, 2, 3, 4. Okay, so this is our years. And these are our wolves. Okay, so in 1995, right, 0 years after 1995, there were 7 wolves. So that's a little bit less than 10. 1 year after, there were 44. 2 years after, there were 81. So it would look like that. And we're going to connect it, and the wolf population is going to continue to grow. So now it says find the value of x, so that should say f of x is 155, and then explain what the solution means in the situation. Okay, so if I want f of x to be 155, right, this is my function. So 155 is 37x plus 7. So we're going to subtract 7 from both sides to get 148 equals 37x. And then we're going to go ahead and we're going to divide both sides by 37. Okay, spoiler alert, 37 goes into 148 4 times, so 4 would equal x. Okay, and then I didn't leave you all a ton of room here, but it says, explain what the solution means in the situation. So think about it, right? Think about what f of x is, and think about what 4 is. Okay, what this means is that, I'm going to turn my paper and write it sideways. It means 4 years after 1995, there were 155 wolves. Okay, 4 years after 1995, there were 155 wolves. Okay, the next thing we have to talk about is a family of functions. It's a group of functions with similar characteristics. For example, functions that have the form f of x equals mx plus b constitute the family of linear functions. The most basic linear function in the family of all linear functions is called the parent linear function, and that's f of x equals x. Okay, so just to kind of re-explain it, because we know f of x is the same thing as y equals x is called the parent function. Okay, so what if I put a 1 in for x? What's y? 1. What if I put a 5 in for x? I'm going to get a 5 out for y. What if I put a negative 2 in? I get a negative 2 for y. Negative 6. Negative 6 for y. Okay, so we connect these dots. Okay, we can even label some points to show us that this like is 1, 1, 5, 5, negative 2, negative 2, negative 6, negative 6. Right? These are all the same, where f of x is the same thing as x, or y is the same thing as x. So now what we're going to do is, on the back, we're going to graph the function and then compare it with the graph of f of x equals x. Okay, so first thing I'm going to do is I'm going to go ahead and I'm going to graph our parent function on all of these, right? So we start here. Okay. There we go. Okay, so I just graphed in pink f of x equals x on all of those. Okay, so now I'm going to graph on this first one, g of x equals x plus 3. Okay, so I know I'm going to start in the y-intercept of 3, and the slope is 1. Rise 1, run 1. Rise 1, run 1. Okay, so this line is going to look like this. Okay, so once you get your line, how could we compare them? What could we say? We could say, gosh, I didn't leave enough room. The functions are parallel. And then we could say g of x has a y-intercept 3 units higher, right? Or even 3 units above. Does that make sense? So the functions are parallel, but this g of x line, right, has a y-intercept that's 3 units above the parent function. Okay, let's look at the next one. It says h of x equals 2x. So the y-intercept is 0. The slope is rise 2, run 1. Rise 2, run 1. Down to -1, like this. Okay, so if we were going to compare these two, we could say the graph of h of x is steeper, right, or more steep, okay, but they share a y-intercept, right? Both functions cross at the same point, 0, 0, but this line is more steep or steeper, okay, than the parent function. Okay, and then let's talk about this one over here at the end. F of x equals -3x. So what we can do, it has a y-intercept of 0, and the slope is down 3 over 1. Up 3 over -1, right? Or we could even go like this. So there is our f of x line. So what we can say is the function, or I'm going to say the functions share a y-intercept, but f of x equals -3x has a negative slope and is more steep, right? Okay, so the two main things that you want to be comparing every single time, we want to be talking about the slope, and you want to be talking about the y-intercept, right? If you'll notice, all of my little comparisons compared the slope, and it compared the y-intercepts. Okay, so it says we're going to compare g of x, let's see, with the parent function, g of x equals x plus b. Okay, so these are just, we're going to talk about in general. Okay, so let's go ahead and draw the parent functions on all of these. Okay, so we're going to draw our parent function. Okay, and I'm going to kind of like box this in because these are going to be kind of like just a general concept here. Okay, so in general, if you have something, you're comparing g of x where it has x and then plus a b, it's going to be parallel, but it's either going to be above your line or below your line, right? Because if you look at it, they're going to share the same slope, right? They're both x, but it depends on what the intercept is. If this is +5, it's going to be above. If it's -2, it's going to be below. But as long as it's just x, they're going to share the same slope. Okay, and now if you have g of x equals mx, where m is greater than 0, okay, you could have a line that looks like this. You could have a line that looks like this. Okay, but what's happening is that you have the same y-intercept, but your line is going to have a different positive slope, right? Puff, puff, positive, puff, puff, positive. So they share the intercept because this doesn't have a, this is just plus 0, right? And this up here, our main parent function is plus 0. So they're going to share the origin as their y-intercept, but if the slope is greater than 0, it's going to be positive. It could look like this. This is a much steeper positive slope, so whatever that m number is, that's going to be your slope. And if m is a negative slope, less than 0, right, it could be really, really steep, and it could look like this. It could be much more flat, less steep, and look like that. But again, they all cross. I kind of made mine look a little janky. Okay, at the origin. So if they have the same slope, if it has a plus y-intercept, it's going to be above. If it's a negative or a minus, it's going to be below the parent function. Positive slope, right, means it's either going to have a slope that's smaller than the parent function or greater, but it could be, but it's always positive. Then negative, it could be more steep or less steep, but negative. Okay, so let's talk about this example. It says a cable company charges new customers $40 for installation and $60 per month for its service. The cost to the customer is given by the function f of x equals 60x plus 40. So your cost depends on how many months, and it's $60 a month plus 40, where x is the number of months of service. To attract new customers, the cable company reduces the installation fee to $5. A function for the cost with the reduced installation fee, right? Now it's still $60 a month, but it's $5. It says graph both functions. How is the graph of G related to the graph of F? Okay, so let's go ahead. We're going to put months on the bottom here. 1 month, 2 months, 3 months, 4 months, and 5 months. Okay, and then we're going to put cost up the side. And I'm going to go by 50s. 50, 100, 150, 200, 250. Okay, so let's just do this one, the original cost in pink. So if you use cable for 0 months, you just sign up, right? You're going to have to pay 60 times 0 plus $40. So 0 months right there. What if you use cable for a month? 60 times 1 is 60, plus 40 is 100. What if you use cable for 2 months? 60 times 2 is 120, plus 40 is 160. What if you use cable for 3 months? That's 180 plus 40 is 220. Okay, so we're going to just connect our dots. Again, I kind of approximated where they would go, but that is what the graph of our line would look like. Okay, so what if they drop the installation fee to $5? Okay, so we don't even use cable. We just have it installed. That's $5. After 1 month, we have 60 plus 5. That's 65. After 2 months, 60 times 2 is 120 plus 5 would be 125. After 3 months, 185. After 4 months, what is that? 245. Okay, and again, it's not perfect, okay, because I didn't use, like actual graph paper or a ruler, but what you can see is what did they have? They had the same slope, okay, so we can say G and F are increasing at the same rate, but G starts lower than F, right? Everyone's bill is going up $60 a month, but this one just started $45 less. Okay, and then it says, what if the monthly fee increased to $70? Write a function for the new cost and graph it on the same graph. Okay, so now it's f of x. Oh, that pen's about to die. Okay, so f of x equals $60 a month. Oh, no, sorry, the monthly fee was increased to 70. So f of x equals 70x. It doesn't say anything, so we're going to say that it's still plus 40, okay? So we're going to start it here at 40, but then after 1 month, we owe 70 times 1 is 70, plus 40 is 110. After 2 months, 70 times 2 is 140, plus 40 is 180. 70 times 3 is 210, plus 40 is 250. Okay, so this, we're going to say that they share the same y-intercept, right? They both start at 40, but this h of x, okay, whatever we're going to call it, the new one, is increasing at a faster rate, right? If we kept it going, this pink line is going to continue right here, and the orange is going to continue to get bigger because you're actually gaining $10. I did not draw that correctly. Okay, per month, right? This one is increasing at 60 a month. This one is at 70 a month.